Lesson 2-3, domain and range of an inverse function. So in lesson 2-2, when we were finding the inverse of a given function, the inputs we call domain and outputs range of the original function are switched. This is because when we find an inverse function, we are taking some original function and solving for x. So what was used to be the input becomes the output, and what used to be the output becomes the input. Let's revisit what we covered in 2-2 by looking at the following example. So just a refresher, if you look back in lesson 2-2, when I say this part, so what used to be the input becomes the output, and what used to be the output becomes the input, that was the interchange that we were doing when we would switch the x and y, okay? So interchange your x and your y values, okay, or coordinates. So in this function of find the inverse of f of x equals negative 11 over 1 plus 3x, we recognize that f of x is actually the y value. So that f of x is going to turn into x. So let's rewrite. X equals negative 11 over 1 plus 3x. Now, when you have a term such as x set equal to a fraction, what you should do to make the solving of this whoops, I forgot to do something. This should be y. My apologies. What would make it easier to solve for this y coordinate is going to be set the x to be over an invisible 1 so that you have a fraction equals to another fraction. And when you do that, what you can end up doing is cross multiplying because you have a proportion. You're going to take the x and the 1 plus 3y, and you're going to multiply those two together, and you're going to set it equal to the other side, which would be the multiplication of these two. Okay, so we're going to cross multiply. So let's get the result of that. So the yellow, which would be x, open parentheses, 1 plus 3y, that would be multiplied and set equal to the 1 times the negative 11, or negative 11 times 1. It doesn't matter the order. We need to distribute. So x times 1 is x, plus x times 3y is 3xy, equals to negative 11. Now, we are trying to solve for y, okay? So here's the y that we're trying to isolate right here. As a matter of fact, yeah, let's just leave it like that. I was going to, you know what, let's just do it like this. I'm going to make it purple again here so that we could see. So this y that's purple, we're trying to get it to be all by itself. So the first thing I need to do is start moving the negative x by subtracting both sides. Get your adding and subtraction out of the way. So this x minus x is going to become 0. So we are left with 3xy equals to negative 11 minus x. Again, I'm trying to solve for y, so I need to get rid of the 3x, which is multiplying by my y. So I'm going to divide both sides by 3x. And in so doing, now my 3x and 3x cancel, and my y is isolated, as you can see. Okay, so once the y is isolated, I have found my inverse function of the given function, and the given function was f of x. So I'm going to put f inverse x because I found it, and it's negative 11 minus x over 3x. And that is the final answer. Okay, so that's a bit of a review from 2.2. Okay, And so we're going to use this method of solving inverses a little bit throughout this lesson, okay? So again, in this little paragraph here that follows, we're just recapping. Now notice, since we're switching x and y, in essence, the domain of the original function of f of x becomes the range of the inverse function, and the range of the original function is the domain of the inverse function. So this here is key when being tasked with the job of finding domain and range of an inverse. Notice that the switch is going to happen just like it happened with the x and y, okay? So there are certain there are certain functions that have domain restrictions. And two of those type of functions are the rational and the square root functions. So we are going to take some time to focus on those particular functions. So right here, we're going to focus on the domain restrictions of rational and square root functions. Okay, so we're going to start with rationals. So the first bold point being underlined here, when a function is defined by a fraction, in other words, when you get a rational function, all right, so let me write rational again, you are going to want to make sure that your denominator value does not equal 0, okay? We do not want that denominator to equal 0. Okay, you cannot divide by 0. It's undefined. Okay, so I want you to notice that in this problem, you are given had to change color there. You are given a function, and the function is g of x equals 1 over x plus 2. Notice it's a fraction. It has a numerator and it has a denominator value. Okay, so I want us to first find the domain and range of this circled green quantity. Okay, so I want to go find the domain and I want to find the range. All right, now first let's find the domain of this function. So to find the domain of g of x, we want to make sure that we set the denominator not equal to 0. Okay, so notice that all I did was take the denominator value and set it not equal to 0, just like I had stated up here. The denominator cannot equal 0. That's all I did. And then when you solve for x, right, the 2 and the negative 2 are going to cancel. So x is not equal to negative 2. So what does that mean? It means that you're allowed to plug in any x value into that denominator value x except for negative 2. So the notation that we use is all real numbers except negative 2. And here's how you write it for interval notation. And you should recognize this from Unit 1 when you guys had vertical asymptotes. This is the notation you would use. You would start from the left. Remember, domain is left to right. You would start from the left and say, I started from negative infinity all the way to the vertical asymptote, which was always depicted by a dashed line, okay? And then you would say you had to jump over that vertical asymptote, and then you would continue all the way to positive infinity. So that's the notation for all real numbers except for negative 2. And that's why I wrote this here as a reminder just in case, okay? So if I know that the domain of G, is negative infinity to negative 2, union negative 2 to negative infinity, that means if I do the switcheroo, the range of the inverse has to be what I just finished boxing in. So I am going to put right here, negative infinity, comma, negative 2, union, -2, comma, positive infinity. Notice I typed or wrote the exact answer that I put for domain of G. Okay, so I'm going to scroll, if you would scroll with me down at the bottom, because we are going to eventually write down the summary. Okay, the domain of G, we said was what? We said it was negative infinity all the way to -2 and -2 to positive infinity. But because we know that inverses are just the exchange, the interchange of the x and the y values of our function, that means or implies that if the domain of G is that, okay, if the domain of G is this, then that means the range of the inverse has to be the same. So I'm going to put the same answer down here. Negative infinity to -2 union -2 to positive infinity. Okay, so I'm done with finding the domain of the function given to me, and I already know what the range of my inverse is going to be, because domain of the given function has to be equal to the range of the inverse of the function. So now I need to either look for this one or this one. It doesn't matter which one I look for, because these two are going to be identical, right? So the question is, what do I look for first? So let's go find that. So again, the conclusion here, to find the range of the inverse implies that you need to find the domain of the function, okay? So that's what we just finished doing. But let's go find the domain of the inverse. Okay, so let me highlight here. How would we find the domain of the inverse? So we are looking to look for this. We're looking for this part right here, the domain of the inverse. All right, so how do we do that? Well, we need to determine what the inverse function is. All right, so let's go find the inverse function, and then we can do what we did earlier. We can set the denominator not equal to 0 and solve. Okay, so let us rewrite. We know that the function is g of x. You know what? I'm going to write it over here on the side to make it easier. We know that g of x is equal to 1 over x plus 2. 1 over x plus 2. So let's start with the exchange. G of x becomes x equals 1. Let me scoot that 1 over a bit. 1 over y plus 2. All right. And because I want to set up a proportion, okay, and I'm going to put this here to remind you on your notes. Set up a proportion. A proportion is when you get two fractions set equal to each other, okay? So you can cross multiply, okay? Okay, so I'm going to set up a proportion so I can cross multiply. So again, I'm going to cross multiply by multiplying x and y plus 2 and 1 times 1, all right? So those are the quantities I'm going to cross multiply. So let's come over here because I don't have space. So x times y plus 2, x times y plus 2 is going to equal to 1 times 1. All right, so then I distribute xy plus 2 times x equals 1. I am going to make the y green here so that you know that I'm trying to focus on solving for y. Okay, so what's the first thing I need to do? I need to subtract. I always add or subtract first. And I got xy. Let's make this y green. Xy equals 1 minus 2x. And then what am I going to do? Well, let me scoot this over again. X y. All right, so hopefully you said I need to divide both sides by x, which would be correct. And so now your y is isolated. So you have solved for the inverse of g of x. So let's write that out. The inverse of g of x is 1 minus 2x over x. So let me box that in. Okay, so notice I got another fraction. I want to know what is the domain of the function we just found. What is the domain? So I'm looking downstairs, I'm looking for this. What is the domain of G inverse? And so we know by the rule, that big bullet up here in bold, that underline, if you have a denominator, set it not equal to 0. So in this box of 1 minus 2x over x, I'm going to want to set my denominator not equal to 0. Well, it turns out it's going to be pretty easy to solve this one, because if I just take what's in the denominator and set it not equal to 0, I'm done. There's nothing to solve. X is already alone. So all numbers except for 0 are allowed. So the domain for my G of inverse is all real numbers except for 0. And you write it in interval notation like this. So I found my inverse domain. So I'm going to put that here. Let's write it in red. Negative infinity all the way to 0, union 0 all the way to infinity. But we know that that one and this one should be identical. So I get to come right over here and fill this out, because if I know one, I know the other. And then you're done. So not only did you find the domain and range of the inverse function, which was the goal, right? That was the goal. You wanted to find that the question was to get this and this. We ended up finding more than that. We actually found the domain and range also of the original function. Okay? So that's how you do rationals. That's how you find the inverse domain and range of rationals. So let us move to another type of function. And we are going to work now with the square root function. All right, so here I want to make sure is that the radicand cannot be negative. Okay, that means on a number line, if you think of a number line, and here's your 0, where are the numbers not negative? Well, to the right of 0. That's where numbers are not negative. Those are the positive numbers, okay? So positive is on this side. So as far as inequalities go, we want numbers to be greater than or equal to 0. We want them to be to the right. So if I look at x minus 2 square rooted, and I want to find the domain and the range of the square root function, I want to make sure that I set the radicand, the stuff underneath the radical, I need to set it to be greater or equal to 0. And so that's what I did right here, okay? Notice it's greater than or equal to 0 right there. And once you've set that inequality, not equation, once you set that inequality, well, you need to solve for x. And in this case, you will add 2 to both sides. And then that's how you end up with x greater than or equal to 2. And that is what your domain ends up being. And this is the interval notation of x greater than or equal to 2. This is also acceptable. But since we've been writing everything in interval notation, I wanted to provide this, okay? So what does that mean? if I know what the domain of H is, so look at domain of H. If I know what the domain of H is, that means if I flip domain to range and I flip H to H inverse, that means this one too has to be 2 to infinity, okay? Because of the definition of inverses. So scrolling down, I'm going to scroll down here. We found that the domain of H went from 2 to infinity, 2 to infinity, because we took the radicand and we set it greater than or equal to 0. Therefore, the range also of the inverse, has to be 2 to infinity because of the switch. Okay? Now, we need to either find this one or this one. Remember? All right. So let's see what we would do when it comes to radicals. So with this square root, we, what are we going to do? Where did I do? Okay, we're right here at this bullet. I lost my train of thought. Now, how would we find the domain of the inverse of a square root function? Well, in this case, what I'm going to have you guys do is proceed by using your knowledge of transformations. That's the easiest way to find the answer, okay? So let's do that. Let's review. So if you look at this little picture here, now, by the way, you do need to recognize your parent functions, okay? I do need you to make sure you recognize your parent functions. For instance, the square root function, the one we're doing right now, y equals square root of x, I need you to remember that that graph looks like this. It always starts at 0, 0, and it shoots out. Or if I'm going to do, what's another popular one we've done? The absolute value of x. The absolute value of x, that one looks like, let's do the little graph here. It looks like a, let me change color, a V. So it goes like that, like this. All right, that's the absolute value function. And what's another one we've done a lot? Let me erase this here, make some space. Another absolute value. So, how could I forget? The parabola. Y equals x squared. Make sure you understand that one. And that one is the U-shaped graph. And of course, the linear equation y equals x. I will do it up here so it doesn't feel left out. Y equals x is the line. Let's do that in green. So you need to know these parent functions, okay? So that you know what's happening to their transformations. So here, with our square root function, we noticed that it is h of x equals to the square root of x minus 2. So we know that when we have adding and subtracting going on within a radical, within parentheses and whatnot, you always do the opposite, right? As far as horizontal movement. So that's where we determined that this graph was moving to the right 2 units. As far as vertical movement, there was no adding or subtracting of any k value. There's no vertical movement here. So it did not go up or down. So that's what happened in this red graph. The red graph is my original square root of x function. And then it became the blue graph, which is the square root of x minus 2. All right. So if I ask you, what is the domain of the blue graph, right? What's the domain of the blue graph? Notice that you would tell me the graph started at 2 and goes to positive infinity, right? Doesn't it start at 2 right here? And doesn't it go to positive infinity? It goes to the right, right? Well, isn't that the answer you gave me up here? It is. So some students say, well, do I have to do this part? Do I need to do the inequality if I know the transformation, can I just do transformation for both of them? Absolutely. Okay. How about the range? Well, the range is the low to the high y value. Well, it starts at 0 and it goes to positive infinity. Okay. So if I was looking for the range here was 0 to positive infinity. Therefore, the domain of the inverse has to go from 0 to positive infinity. So transformations can help so much when one of your problems ends up being one of these 5 main parent functions that we are focusing in algebra and in pre-calc. Okay, so the domain of h inverse of x, if you want to fill out this piece right here, is 0 to infinity. Okay, because it has to reverse. Okay, last section. Let's move up a little bit more. We're almost done. So in the last section, again, reiterating that all you need to know is your parent function to be able to do sometimes these problems. And here is an example where you can just do parent function all the way. All right. So here we go. Given f of x equals x minus 1 squared minus 4, find the domain and the range of f inverse of x. So let's write out the transformation of this parabola. This is a quadratic equation, okay? Our original function, I will write it out over here. Our parent function is y equals x squared. Let's write the parent, okay? And so obviously something has happened from y equals x squared all the way to this function. Something has happened, right? Well, the minus 1 happened and the minus 4 happened. So what does the minus 1 do? Well, the minus 1 causes the graph to move 1 unit to the right, right? And then what did the minus 4 do? It moved down 4 units. Okay, it moved down 4 units. So pictorially, what does that mean? What does that look like if we were sketching? All right, so let's see if I can draw a straight line and another straight line, and then make some tick marks here. Let me set up some graph paper here for us. So let's give us some imagery. So we know that this is a parent function of y equals x squared, so it is a U-shaped graph, okay? It's a parabola. U-shaped, it's a parabola. All right, so we know the original graph looks like, we did it up here. Where is it? Right here. Okay, so that's what it looks like, and that graph moved. It moved how? Well, we said it moved to the right 1 unit and down 4 units. So let's do that. To the right 1 unit. So it moved to the right 1 unit and then down 1, 2, 3, 4. So right there, I have to put my vertex. And then I know it's going to be a U-shaped graph. I'm just sketching, right? So I know I may not have the right width, but it's just a sketch, okay? A sketch to help us determine domain and range. So using this sketch, what is the domain of my f of x function? This is f of x. Well, my graph goes to the far left and to the far right, so it's all real numbers. That means if I got domain of f of x, I can do the range of f inverse x. Negative infinity to positive infinity, okay, because of the exchange. All right. What is the range of my f of x? Well, my range, it started as low as negative 4. and didn't go any lower than -4. Started right here, and it's been going up forever. So that means my range starts at the lowest value of -4 and shoots up forever. And because I know the range of f of x, I know the domain of f inverse x. So -4 to positive infinity. And that's how you find the domain and range of your inverses of functions. Hope that helps. Thanks for watching.